Just want to get rid of these. All right, let's look at just a regular old set. So here's how we define it. So let's define a set of strings. Okay, so here I'm and again the principle is that I declare the type in the most abstract way possible, and of course I can't instantiate a set because it's an interface, and so I'm going to do a hash set, and this will hopefully show how hash set kind of just mixes things up according to some weird rule it has under the hood. The way you define it is, again, with these, they're called generics. You don't have to worry about what that name is, but just know that these strange angle brackets. This tells me that this set can only contain strings. And then when I instantiate it, if you don't put these little diamond things in, it kind of complains about a. Okay. So it'll actually work without it, but it complains. So, all right. So. Oops. Right, so we add things in the same way as we've done with all collections have this add method. We do it just like the list. Right. Now, and just as with lists, it has a nicer toString. So I can just, if I just print, then it, unlike the array which just gives gobbledygoo, it actually shows you what the contents are. That's all collections more or less do that. Okay, so I added them in this order, and it gave them back to me in this order. It said and I don't care about the order, so it now it doesn't let me add another one. Oops, now see that actually. All right, so if I try to add him again, then he doesn't go in. Okay, so here are some things you can kind of do with them. I can now, is anybody going to have angst if I'm now, see, because I define this as a set, I can, this is legal. If I define this as a hash set, then this would not be legal. So let's see what a hash set, a linked hash set looks like. So if I just do exactly the same calls here and do exactly the same print, okay, then we will see that with the hash set, again, they come up in some arbitrary order, but in the linked hash set, they come up in the order that I've added them. And again, they don't allow me to put this extra one. All right, so let's add a few more. Might have to ask your grandparents about who these guys are. Yeah. Okay. Okay, so now, I mean, we can actually query them. So, for example,
Can you say the part about the set new hash set and how it can be a linked hash set? What was that comment? So you were able to make Stooges a new linked hash set below.
Correct. But see if this.
Okay.
See if I'd done this, then. Oh yeah. Actually, this allows that because linked hash set is a subset of hash set, as it turns out. But
linked hash sets is also a subset of set.
Yeah, it implements. They both implement set. As it turns out, linked hash set is a subset of a subclass of hash set, which is why that worked. But normally it, like I said, the what I like to do, and it's kind of more of a personal preference that usually works out fairly well, is to define the type in the most abstract way that doesn't paint me in a corner. Okay, so some things we can do is we can query these with contains. Okay, so there's a contains, and that tells me whether or not something contains a value or not. So contains kind of does that. Now let me give you an example of using an iterator to iterate through. So if I want to iterate through and this is sort of my standard oops. Okay, this is one of the standard patterns for using an iterator to step through what these are, and it'll step through it pretty much in the same way as we did for lists. And the call to next is what advances it to the next. So here it's going to print out what I had there. Now, if you remember, when we had a getter method for an array, I emphasized that it was important to clone the arrays. Now, it turns out that you can clone these collections, but it turns out that it's really clumsy. You have to do casting and other stuff. A better way is to actually create a copy. So I can create a copy of this. And remember, one of the arguments, and actually we can kind of see what these are. Again, as with a list, I can give it an initial capacity. I can give it this thing called a load factor, which again I never use. Or we can give it any other collection, including we can give it a list, or we can give it anything. And what it will do is, if we do that in the constructor, then it will put all those in there. And we see that because I made this a hash set now, even though I put the linked hash set in, which had a particular order that I'd added them, once I put them in a hash set, it mixes them up again. According, and there's no predicting how, I suppose the only way to predict that is if you knew the details of what its hashing function was, then you might be able to predict it, although even then, again, the way these hashing functions work, if you change one little thing, it just becomes completely different. Okay, so that's a set. We can also let's put some doubles in. Remember, I can't put lowercase d's in, but remember we have. I'm going to just put a bunch of random things in. Oh, let's only put 10 in. Oops. Oh, let's do a next Gaussian. All right. Okay, so you see that. Let's try it. Let me do a for each on this again. So now I'll also illustrate. All right, so here's the for each. So there are actually a couple of things going on here. I can use the for each if I'm going to iterate over the whole thing. And now notice that my variable is lowercase double. So the other thing that's happening is this is auto boxing or auto unboxing. See, so even though the contents of this set are doubles, see, it auto boxed going in. It turned from a lowercase d to an uppercase d. And then coming out, it says, you see what it's doing is it's saying, oh, I see you're pulling out a double object and you're trying to put it into a double primitive. And so I will unwrap that for you. And so we see that, again, the order is kind of arbitrary, and this isn't necessarily the order that was in there. Now,
if you put it into, if you took on a hash set, you did, so randoms equals to length, or yeah, length hash set, will put it in order as it.
It'll put it in the order that they were generated, and
okay.
Yeah. So again, the difference is here. Now, what these values are, these are Gaussian random variables, so they're just kind of coming in all weird. The final thing is supposing. Let me come back to this for just a second to show how to. Supposing I want to remove something, but remove it based on a criterion. And that criterion can be almost anything. But here's an example where I have to do something a little bit different. So okay, supposing I want to remove Shem because he kind of left after, all right. So the thing is that while I'm iterating through, so supposing, all right, let's just try to add it. So if the next one, if it equals, again, I want to use equals. Again, I can. Okay, so what am I doing? I'm searching. I have a set of stuff. I have a criterion. I mean, what is that criterion? I mean, it could be something like this, where the string is equal, or it could be, almost anything. And I want to remove it. And this looks like the compiler's happy. The compiler doesn't care. The compiler, as far as the compiler is concerned, this is a legitimate call. This is a legitimate call. Everything is fine. All right, so let's try to see what happens. What happens is I get a lot of red. All right, so let's take a look at exception in thread main, Java util concurrent modification exception. And where is it? It's pointing, it's deep inside linked hash map in this case, but it got called from here. So what happened was, I mentioned this yesterday, but like a lot of things, sometimes I feel like I'm talking to myself, but that's okay. I used to have multiple personality disorder, but we're getting over that. Okay, so what's the problem? The thing is, remember I said that, see, these iterators set up a certain state under the hood, and the iterator expects the collection that it's iterating over to not move, right? So how can you do this? Well, the way to do it is not with this. This doesn't work. I use the iterator. Oops, so this doesn't work, but if I meet the criterion, I can use this. Okay, so what this does is remove says, okay, I will remove the thing that you just looked at. And there's a similar one for if I want to insert stuff, but all right, so let's see if this works. And it does. See, we notice that now Shemp is gone. Okay, so that's sets. Now let's look at sorted sets. And we'll have to continue. I'll get to a certain point on this, and then it'll have to be continued at a later date. All right, so let's look at sorted set. So sorted set. Let's do integers. Remember, I can't put ints in. And the only concrete implementation of this, of sorted set that Java provides is something called a tree set, which is that red-black tree that I was mentioning. There are a bazillion other ways to have a data structure that keeps things in sorted order. Or again, it actually doesn't keep them in sorted order under the hood. Under the hood, it has one of these red-black tree things where it kind of puts stuff. But what it does is when you start pulling stuff out, it always pulls them out in the right order. So let's okay, so let's just put a number of stuff in. Oh, I want to do this differently. Okay, do you see what I'm doing here? I'm again in the for loop. There are three items. One is the initialization, the ending test, and then the increment. So here I'm starting at 5, and I'm going down until I hit -5. -5. Thank you. All right, and in fact, let's print this just to see how this evolves. Okay, so I start with 5, and then when I put 4 in, notice 4 comes before 5, etc. So at the very end, what I have is I have things in sorted order, even though I haven't put them in sorted order, increasing. I've put them in descending order. Okay, so that if I want to keep them, I mean, here's another. So let's do the same thing we did before with Gaussians. And let's just sort of add a bunch of random ones. So okay, so just printing these out, we will see that they come out in sorted order, unlike our sets before. So either both a hash set and a linked hash set, they'll come out in random order. But here, I'm generating them randomly, but they come out in ascending order. Now, what if I wanted to, I think I can do this in our any time. I think, okay, so let's say I don't want my integers to be in ascending order. I want them to be in descending order. So there are actually some built-in things. All right, so what I'm going to do is I'm going to implement implements. This is how I do it. Again, we know how to implement an interface, right? We say implements, and okay, I can't find the symbol, so first I need to import it. And then now it says, implement all abstract methods. And again, these are some of the, again, Java added some features, but really the only abstract method that I need to implement is this, the compare method. And this says integer O1 and O2, right? So I want this is all I need to do. Remember what this does is this is going to return 0 if they're equal. If I have two values that are equal, then, and there's auto boxing going on here too, by the way. So it says, all right, you've taken integer capital I and put them into an expression whose context is an int, and so I'll unwrap that for you. Okay, so let's say if O2 is smaller than O1, boy, did I might have this backwards. If O2 is bigger than O1, this will be negative. That means the second one is going to be less than, and it'll return a negative value. Okay, so now here's how we do this. So here's what I can do. What I'm gonna do is I add that's as to the constructor, new tree set. Oops, tree set. And descending. Okay, so instead of my other constructors, I give it an instance of the comparator I want it to use. And now, because I'm lazy, I already have all these numbers that are kind of going from -5 to +5. And so now you say, well, before we use the constructor to stick them in, but there's actually a method I can do. I can say add all. the numbers that I had. Okay, so that's a very convenient one. And that should given to me in descending order now. Now, naturally, I cherry-picked an easy one. And actually, there are ways of kind of, Java has some built-in stuff because this is something that you often do. But nevertheless, it's important to be able to define these. We'll talk more about this tomorrow. And because these comparators can get a little involved depending on what the criterion are.